Okay, good morning, everyone, and welcome to today's guest lecture event, organized as part of your SABE lecture series and also Theories of Architecture and your Interior Architecture Design Studio 4. So today's session is basically part of your Tectonic Dialogues from Suzhou to Kuala Lumpur. It's part 2, and this is an ongoing collaborative lecture series between Xi'an Jiaotong-Liverpool University and UCSI. Through this collaboration, we are invited to explore contemporary design discourse ranging from geometric systems, computer fabrication, cultural anthology. And we basically hope you guys can reflect more on how architecture continues to evolve in this increasingly globalized context and also in this emergence of AI and new technologies. So it is my pleasure to introduce our two speakers today. First, we have Assistant Professor Dr. Zhelun, who holds a PhD in Architectural Engineering from Sapienza University of Rome. His research focuses on the impact of the Fourth Industrial Revolution on architecture, engineering, and the construction industry. And his research is interesting because he explores architecture in extreme environments. And what I mean by extreme is it looks into sustainable habitat design for extraterrestrial settlements and space exploration. So space architecture, yeah, like space, not our space, but up there in space. So joining him is Assistant Professor Dr. Yan Song, an architectural researcher whose work explores AR and VR, immersive design, robotic fabrication, and advanced digital fabrication techniques. He holds a degree from the Bartlett School of Architecture and Liverpool School of Architecture, and has lectured and conducted workshops internationally across. And of course, given the, he works with a wide range of cutting edge technologies, immersive design, especially at parametric design, generative algorithm design as well. All of these things which are, emerging today, buzzwords today, and I think it's very timely that you guys yourselves need to be aware of such technologies and how to actually utilize them moving forward into the future in your career. So we will allow our speakers to give their lectures first, and only after that, I will pass this session to Dr. Leong, who will help me moderate the Q&A session afterwards. And you guys will have the chance to ask your questions as well. So please join me in giving a warm welcome to Dr. Zhelun and Dr. Yan Song, please. So all right. So we will begin with Dr. Zhelun.
All right, can you hear me? I see my screen.
Yes.
Okay, sorry. Oh. All right, good morning, everybody. So thanks for introduction. And I am Dr. Zhelun. I come from Department of Architecture, Design School at Xi'an Jiaotong-Liverpool University. And it's a pleasure of mine today to give this lecture about tectonic dialogues from Suzhou to Kuala Lumpur. So these are few information about me. And I'm very glad that Emma mentioned my research interests. And here are the institutional roles I'm currently covering, which are the Polar Zones Architecture Committee from Chinese Architecture Association, Space Habitat Committee from International Astronautical Confederation, and Aerospace Committee from Engineers Association of Rome in Italy. So today I would like to present my research interest, my teaching activities, and my sum of the outcome. And so about research interest, I would to share this part of my research, which is about bricks and interlocking systems. So the bricks is a type of building component used in also traditional architecture to build walls, pavements, and other elements in masonry construction. So usually they are laid in courses, right, and joined together with mortars, adhesives, and other or by interlocking system. So beside the bricks, we have also blocks, which are similar term referring to a rectangular unit composed usually of clay and concrete, but they are usually larger than a brick. So we have, since this is a traditional architecture, we can find its implementation also in Roman architecture, and this is a picture taken from Forum Imperiale in Rome, which is 2,000 years from now. And also we have some innovative and modern application of the brick system. And this is a very nice, let's say, modern interpretation of this system, which is Xi'an Boutique in Amsterdam. And you can see how modern, let's say, material, which in this case is the glass bricks, can be merged with the traditional bricks, which is usually used in the North European masonry system. To use the mortarless brick. So mortarless brick construction are usually achieved via interlocking system, and they have several advantages in increasing the construction productivity, reduced construction time and labor, and reduced consequently the construction cost. So because of its technological simplicity, mortarless brick construction is more appropriate for many local communities than the conventional, let's say, mortared brick techniques. As you can see, and you can imagine from the Lego system how easily it can be built, or we can have fun in putting together these small pieces. So benefits and characteristics of interlocking bricks are self-aligning, so they can fit to each other without any adjustments, and then are orientation specific. So if they will not fit if wrongly placed, they are usually modular, and they have very tight tolerances. And usually they are featured from few elements. So you will find a lot of elements and which are similar to each other, because in that case, because in the interlocking system and modelless mechanism, we need to simplify the management during the production and construction. For example, for prevent confusion between one to each other. On the underside, they are featured of co-resistance, meaning that the effective locking allow dry stacking to achieve straight and stable block wall that can withstand vertical and horizontal forces during and after the construction. So all the bricks, they are interlocked together, they work as system, they collaborate to bear all the loads. Okay, and this is for the co-resistance. So here are some examples of modelless and interlocking system. In this case is a small system. You can see how the blocks are shaped to fit to each other. And finally, they can form a quite complex and interesting shape, like in this case, this tower. And we have also many explorations of interlocking system, and this is done by Dr. Hua Hao from Southeast University. And they have designed small type of blocks, and they are interlocking to each other with this mortise and tendon system to form a wall. So this is a bigger example, and this is a pavilion made by Mohan University, and they are shaped, these blocks, in a not conventional shape, and the entire system works as one single object, and they can resist to the forces. So we have also many modern architecture using interlocking system, and this case is the Metropole Parasol in Seville. And in this case, you adopted a waffle structure to combine these panels together via interlocking system. And you can see the shape. The overall shape is quite ambitious, but each component is quite simple, and as their panels, and they use the digital fabrication process to shape these complex curves. And these are another, and there are all the examples of interlocking system and via waffle structures. And in terms of application the space, it is really interesting that we are exploring how we are going to build in this extraterrestrial environment. And we are exploring how we can use in situ materials like the lunar dust to 3D printing the building components. So this is an example from Norman Foster and partners for the Moon Village. So they are trying to use 3D printings to build small elements, and they, as you can see, can interlock to each other to form this shell for future space settlements. So this application of using traditional techniques via modern construction strategy is actually very cutting edge and has a large of application. So what we have done in the last semester at XJTLU is that we have asked students, in particular in my groups, to design an integrative system formed by interlocking bricks via digital design and fabrication process. So students, they design and build a pavilion, which is approximately 3 meters, 3 times 3 times 3 meters using this system. So all the elements must be geometrically interlocked with each other. And we ask students to use hot wires cutting of EPS panels. The equipment that we have here, and we used the equipment that we have here in the Department of Architecture, in particular a 6-axis robotic arm cooker, and we have a hot wire equipment of the size of 65 times 45 centimeters. So the material or EPS panel of the size 1 meters maximum and 6 centimeters in width and breadth. So here are some examples of what is the hot wire technique, what it can do. And as you can see, we can shape different and very attracting forms using these techniques. Here are the team members. So I supervised 26 students, and then they have been split into groups of small bricks design, the pavilion overall design. Group G investigated the structure and the mechanism of the pavilion. And then Group 4 investigate the robotic arm management with the path design. And then Group 5 investigates the material, which is really related to the structure. So you can see all these groups, they work with each other in order to have a quite similar, also in real construction groups. And they need to establish and have regular meeting to each other to check the progress of each other and try to communicate what is affecting who. So here are the results. We start with the material study. So we have investigated the material that we have, which is EPS panel, and they have explored, investigated the density, the mechanical properties, what's how maximum load bearing of this material, as well as comparison with other materials, and what are the benefits and the advantage that EPS panel, this particular material can bring. We have also investigated different mechanical and the structural performances of the material and check what is the maximum load-bearing performance of this material in order to design appropriate shape of the proposed system. Students also run a case study with the similar material or other shapes. In particular, we have also explored the traditional tenor mortise system here in China, and from which we extracted some inspiration for our interlocking system. So here is the digital or the agreement. What would be the digital fabrication process? What are the max precision, and how these bricks can be produced and in masses without cutting each other? So that would be waste. That would be a lot of effort in terms of energy and material. So we explore the different way to cut all the bricks at the same time, since they are modular. We have also proofread the path editing, and we have also resolved the problem of the errors during the production process, and also how the 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 final bricks can be optimized for the small pieces. For example, during the production process, we will notice that we cannot cut very small openings, otherwise the material will lose the structural performance of the particular point. So this information has been communicated with other groups, for example, the groups in charge of the bricks design. So they have consequently adjusted the openings of the bricks. And here are different shapes and different paths to edit the blocks of this pavilion. We have also the different alternatives of the shape, since all the bricks are modular. So the entire pavilion can have different shape and alternatives in terms of aesthetic representation. During the process, we have also the student also gets chance to have a notice in terms of, let's say, communication with the supply chain, and we notice that we can also require directly shape of the blocks, which is have the same depth that we require, and this will bring benefits in terms of material saving, less cutting in our lab, and optimizing the workflow. So, and this is a comparison if we cut each pieces from initial 1 meter block, and that will be produce a lot of material waste, and which is not economically and sustainably feasible. Finally, we have also designed the assembly manual. So the entire process acted as a Lego process, and then we actually had fun in assembling all the pieces together, following this manual. And this is again the validation of how easily the digital fabrication process of interlocking system, since the entire construction process took more or less 6 hours. And this is the final result. So, and here are some construction details, but I will show this video that can summarize the is the video playing? Okay. So this is the initial process. We design all these blocks by parametric design approach, which means all the parameters, all the sizes of the bricks can be controlled and customized, or can be shaped as the needs. So this is the designing and exploration of the small components. And we avoided to carve too much each block to maintain still the structural resistance of each blocks. And here are the modular system of NV. And this is the design process. We tested the overall structure with digital design tool, in this case, Karamba. And this is the simulation of the cutting. So before we actually cut each component, we run a simulation on a digital platform to test the validity, to validate the process before. And this is how we cut all the blocks in mass instead of from one single block each, and one per each time. So here is the fabrication and the assembly process. So we labeled all the components, and we split them into in this area, and then we follow the assembly manual to put all the pieces in the correct position. And the process is actually quite fun. And our team, we collaborated together to build the blocks, single parameters, and other group worked to put the blocks on the pavilion. So the entire process was very efficient. and it's the final top placing of the pavilion. Here you run with a drone to take some pictures of the pavilion from different angles. And that's all for this small experience. And then the next part is the introduction of our Fab Lab. So we would like to have you during the summer in our fantastic campus for this workshop. And I would like to introduce our Fab Lab to introduce what we have, the equipment that we have, and we hope that we can have some very nice project and outcome from this project. So starting with the laser cutting workshop, we have 5 laser cut machines, and we can cut cardboard, timber board, and acrylic. And here are some effects. So you can just have a DW file and label the different depths with different layers, and we can have the laser cut of different, let's say, effects. Right, and we have also the laser cut for metals, and as usual, you can just have the DWG file and with different line properly labeled, and we can cut iron sheet, steel, aluminum, and copper. The maximum depth that you can cut is 2 to 3 millimeters. We have also 2 CNC machines that you can use to carve and mill wood and foam. Here are some parameters, and this is on the left, you have the 3D model in Rhino, and then we need to edit for 2-part simulation, and here is the process model using the foam. We have in total 26 FDM 3D printers. They have different parameters, different size, but we have also several stereolithography 3D printers, and they are usually more precise. They provide more precise outcome than the FDM printers, but they will require more time. We have also robotic arms, 2 UR and 1 KUKA. Our Fab Lab is equipped of several equipment for robotic arm, including the plastic 3D printing accessory. We have the hot wire foam cutting accessory. We have milling accessory, and the gripper and the vertical ray. Okay, and this is the KUKA, which has the more payload, maximum reach. It's bigger. It's a state of art 3D printer, which is allow also concrete 3D printing. And yeah, that's it. This is the end of my presentation. So please let me know if you have any question. And I will leave the floor to Dr. Yan Song for his presentation.
Thank you so much, Dr. Zhelun. May I also now invite Dr. Yan Song with a second lecture. Thank you.
Okay, let me share my screen. Okay, can you see the screen?
I can see the screen. I think it's all right.
Okay, thank you. Okay, so thank you for the invitation from UCSI, and it is really a great opportunity for us to share our research by this guest lecture opportunity. So what I want to share with you guys is my own research, also related to teaching, to my own research and some practice examples. So the title of today's guest lecture will be the mixed reality in architectural education and practice. So at the very beginning, let me just do a very brief introduction about myself. So my name is Yang Song, and I am currently the assistant professor from Xi'an Jiaotong-Liverpool University, XJTLU, and I hold the PhD degree from University of Liverpool, as well as a master degree from University College London, the Bartlett School of Architecture. And then I was working with, used to work as a teaching assistant and a research assistant for University of Liverpool and Southern Denmark University. So most of my research, they are related to visual technology as well as digital fabrication part. So at the very beginning of my research, I would like to share you with a very interesting example. This one, this is a very interesting game that released in around 2016. And I don't know how many of you have already played with that before, but I think during that period, this game is really, really popular, right? So this game is the first game that we call it as MR game. So why we call it like this? Because different from the other games, it is like a more interactive way for you to play with the digital things upon in the real physical world. So let's have a look about the video of this game in case that you haven't played with that before. So it is more like catching the Pokemon game, right? So what you can see is like you can see the real physical world and people they are walking at the background as well. And then you can see this kind of virtual Pokemons pop up in front of you, which are pure virtual. So this is the game that they first connect this physical elements or physical environment with the digital things. So play with them together. They call it mixed reality game. And it is popularized, really popular during that time. And I think people don't have this kind of experience before. So if you haven't tried this one, maybe I suggest you to try it as soon as possible to have experience by yourself to trying to immerse yourself in this kind of mixed reality environment. So after you get some ideas about this kind of physical and virtual things, probably you normally will heard about several words which they sounds really similar, but actually they are not same. So they are something related to the immersive technology, which we almost call like VR, AR, MR, and XR. So I think the VR part may be more familiar with you, and you heard about this words pretty a lot. So the VR is a virtual reality, which means that you are experiencing something like pure virtual. So no matter about the elements that you are seeing or the environment that you are entering, they are purely virtual. So in that case, we call this kind of experiments as virtual reality. So when we call something as augmented reality, so the augmented reality means that you can see the physical world plus some virtual image or some virtual information. So when you have the experiments about some virtual things really happened in the real physical space, this kind of experiments, we call it augmented reality. So I think most of my students, they get really confused when they heard about VR and AR, and they normally use different words to describe their experiments. So I think if you're really interested in that at the very beginning of this technology, you have to make yourself more clear about these two words. And when we talk about mixed reality, it means that you are trying to create a real a physical world, but not in a physical method. So it can be the physical world are translated by some cameras. So you have the physical environment feeling, but actually this is not real. So this kind of combination between the fake physical with the virtual environment, this kind of things we call it mixed reality. So in case you cannot tell them, you can all use XR, which is extended reality, to explain all these kind of feelings. So I think at the very beginning of this lecture, it is really great for you to have some basic idea about these kind of words. which are describing something similar, but also different in the other way. So apart from the words, I also would like to introduce several devices also that we currently have at XJTLU. And also, if you are interested by yourself, you can buy some to explore by yourself as well. So the first device that you can see is HTC Vive. I think this one is pretty popular, let's say maybe 5 or 10 years ago, when the virtual reality become really popular by that time. So I think maybe some of you has already tried this device before and try to play with some VR games and trying to see some VR videos, right? So this one is pure virtual, which you cannot see the physical environment through the device. And what you can experience is just like the virtual reality things. So this is the HTC Vive, and if you want to have this kind of pure virtual experiments. So later with the technology development, one device, which is called Microsoft HoloLens, just appeared. So you can tell from the pictures, they are pretty different. So for Microsoft HoloLens, it is just like our glasses, which we can have this kind of transparent goggles. And then they project the virtual information as well as virtual image in front of you, just right on the transparent goggles. So in that case, it means that you can see through the goggles to check the real physical environment, as well as you can see the digital informations. So this device, we always call it AR device, that you can check both environment as well as the holograms. And then the last two devices, they might be really familiar to you guys, which is the Meta Quest 3, the most popular MR device, as well as the Apple Vision Pro, the most famous MR device from iOS, right? So they are called MR devices because you can see from the pictures, they are translating the real physical world through their cameras. So what you can see through the goggles or through the glass, it is not the real physical environment, but actually you can have some feelings of it. So this is what we call MR, which they are merging the physical environment to you, but actually it is not the real one, but you have the feeling. So these are the most popular devices if you are interested in this kind of immersive experiments or immersive visual guided fabrications. So you might use these kind of things later. And the device that we are currently use at XJTLU, they are the Microsoft HoloLens as well as the Meta Quest. So here is a very quick demonstration that from the Microsoft HoloLens team about this very famous goggles. So you can see this goggle contains several cameras inside of it, and also it contains a very unique projector, which is this one showing on the screen. So this one can give you a hologram projection, which using the reflection to project it in front of your eyes. So what you can see is like, you can see all the digital information through this transparent goggles, as well as you can see the real physical world. So at the very beginning, this device is widely used for some industrial design, which you can see the elements information with the element itself just in front of you. And then later, this kind of technology has been widely used for some medical surgery experiments. So they can do this kind of simulation or practice before they actually do the physical surgeries. And currently, this device is really popular for this kind of immersive theater, as well as for some immersive museum to create the more dimensional feelings about the content. So with this kind of advantage, as well as the properties, architects are trying to finding the advantages and apply this one into architecture fields. So these are some very popular fields that architects or researchers, they would like to try the immersive technology into architecture fields. And also I have tried some of them as well. So they are immersive design, MR construction guidance, and MR human-robot collaboration, as well as MR immersive experiments. So later I will show you several cases that I did at XJTLU, which are under this kind of research field of applying immersive technologies. So the first project that I would like to share with you is called Timber. So we did it together with Dr. Zhelun as well, because this is the same course which we've facing this course to year 4 student at JTLU, and this course is called Architectural Technology. So we are trying to use repetitive element and trying to use like very simple connection method to achieve some temporary structure, quick fabrication, quick assemble for that. And this kind of shelter, they are required for some duplicate surfaces, which are normally difficult for them to do using the conventional method. So you can see on the left-hand side of this slides, you can see we are creating this kind of a triangle-ish connecting system, which allow they have some flexibility of changing the surface angle, as well as keep the simple method for connections. So for the materials, we are using the pure standard wood stick, as well as the unitized 360 degree connection aluminum connectors. So after we defined the material as well as the design language and connection language, students are translating these kind of things into Grasshopper script. So they, at the very end, they are connecting the Grasshopper script with their Microsoft HoloLens goggles. So what you can see on the right-hand side is actually the design model before they do the fabrication. So students, they can change the parameters and then see the final outcome in real time. And they can wear these glasses to the site and feeling the spatial qualities by themselves before everything is done physically. So this somehow changed the idea of the student for doing architecture design. So actually, like what they did for now, they are doing the script in front of the laptop, and they are trying to somehow fitting the spatial quality with the laptop screen, which I don't think it is a good method, but by let's say by giving the student with this kind of technology, actually they can feeling and see this whole space into a one-to-one scale. So it gives the student more feedback to, let's say, modify their spatial design to a next level. So this is like a very initial idea that why we are creating or why we are applying this immersive technology to this course. So not only for the design process, but also we are applying the immersive technology into the fabrication part. So you can see during the fabrication process, the students, they are wearing the goggles and then achieve the whole complex geometry shape fabrication. So what they can see is just like on the right-hand side, they can see the red color of the highlighting wood bar. And what they need to do is that they just wear the glass and place the wood bar there and then fix the connections. So by this kind of method, especially for creating a very complex duplicate double curved surfaces, it really saved their time as well as increased the accuracy of the final outcome. Because let's say for the conventional method, we need to measure them, and also we need to convert all the information from the 2D documents and then translate that into a 3D physical space and measure them and fix them. So that is a kind of time-consuming process, and we cannot promise the accuracy of that. But wearing the augmented reality goggles, they can actually see the elements on set. So what they need to do is that they just need to follow the hologram and then they place the wood bar and fix it. So it's kind of a very quick method that they are actually see all the 3D model on set, and what they need to do is they just need to place and fix. So you can see on the right-hand side, these are the real screen recording as well as the screenshot from Microsoft HoloLens. And actually the fabrication guidance, they are quite simple and user-friendly. So we have around 20 students, and we finished the fabrication within half a day. And then we have around 300 pieces of connectors as well as 100 pieces of wood bars. So compared with the amount of the materials as well as the complexity of the shape, you can tell how efficiency this AR system method is, right? So you can see on the left-hand side, they are the this is the final outcome of our timber pavilion. And on the right-hand side, that is the rendering for our final design outcome. So the shape is kind of similar, as well as there's not that much tolerance. And I think all the tolerance, it is within our acceptable range. So here is a video that demonstrates this process. So you can see at the very beginning, we did several different double curve geometry studies, and then we apply our method there. And also we do the simulation in augmented reality method. And this one is assemble simulation of the assembly set sequence. And then before we do the physical assembly, we actually did several material tests to make sure that this material can achieve whatever we want from the design process as well as from the fabrication process. And these are the materials that we prepare for this pavilion. So you can see everything, they are standard with same length. And for the connectors, they are standard. So it will be really easy for us to do the full speed fabrication for some, let's say, the temporary structures. And this is the assembly order rehearsal in AR environment. So after the student, they know how to assemble that, they know the assemble a sequence, they will have a full speed assemble with the guidance of augmented reality method. And also at the very end, we add this kind of bamboo strap as a decoration to cover this whole wood structure. So this project explores about how to do design, how to do fabrication with the help of augmented reality. And we also get really great feedback from our students, which they think that they have like more understanding about their space design before the fabrication, before the physical fabrication outcome shows up. And also they are really enjoy the fabrication process because they cannot believe that they just use the glass and their hands to build something like such a complex geometry shape. So not only we are applying this immersive technology to year 4 students, we also apply that to some lower level students from year 1 and 2. So this is another workshop that I did with my colleague together, Mona, Juan Carlos, and Gergely. And we create this kind of shelter design facing for year 1 and year 2 students. So you can see all of this design, they are connected back to Grasshopper. And the student, they have this 1 to 50 model, and they can do their design on the model and change the point in AR. And after that, we will send all the digital design into the real site, so they can wear the glass to feeling the spatial quality of that. And at the very end, we fabricate it to a real scale. So this is also a kind of a very preliminary attempt for applying this immersive design technology into our year 1 and 2 design studio calculations. So moving that a little bit forward, me and my friend who is from University of Tokyo, Erisumi Tomo, we did a workshop together. So this workshop is a little bit different from the timber AR pavilion that you just see. So we are trying to use some recycled wood material and also add human-machine communication, human-machine interactions to the whole process. So this workshop is called Wood Cycle, and it was held by Kadria conferences in Tokyo in 2025. So you can see these three images, they are like a very representative image for this workshop. And the student, they do this kind of AR assisted assembly, as well as they do the design. So what's showing on the top right image is like this image is demonstrating the human-machine collaboration or human-machine communication. So actually the fabricator who is wearing the AR glass can actually see the target location. But if you remember at the very beginning, we are trying to use the reclaimed material. So actually the material, they are from nature. So we only have like one surface smooth. The other surface, we are keeping the wood textures as it is. So the fabricator need to think about how to connect or which surface need to be connected to maintain the whole structure stable. So this is a kind of communication between our fabricator as well as our AR machine. So let me show you a quick video about this workshop. So we have 6 students for this workshop who doesn't have any AR experiments, and we achieved this workshop within 3 days. So at the very beginning of the workshop, we went to a forest near Tokyo, and we are trying to get some dyed wood material to use for this one. And also we use several material from my friend's another project, which are the waste material from this project. And then after we collect the material, we are using the augmented reality method to do the real-time 3D scanning of them. So you can see we got this kind of digital twins and digital data for all the reclaimed material that we have. And then we did the categorize of them. So we are trying to categorize them into 3 types. So after the material preparation, we introduce the student with this AR immersive design process. So actually they are playing with the volume to create some installations. And then after the volume is sized, the volume is connected directly with the algorithms in Grasshopper, and then this kind of wood component are generated automatically. And also the student, they can change the shape of the wood in the AI environment. And then after the design is finalized, we get into the AR assisted fabrication process. So they can select the specific wood material that they have to following the AR guidance to finish the physical fabrication. So during this fabrication process, the human workers is actually have the communication with the AR device, trying to find the perfect connecting surface. So this is the final outcome of part of this installation, and this installation was exhibited with the Kadria conference. So because we only have 3 days to try this, to try our idea. So later we are currently now developing this one more into an architectural proposal for some walls as well for some columns. So there's another very interesting project that happened at XJTLU last summer. This was a summer workshop, which is called Bamboo Fusion, that I did that together with my colleague Leong Jiang, as well as our friend from AA Architecture School, Hanjin Kim, and Hao Tianman from Hong Kong University. So this workshop is called Bamboo Fusion, Augmented Architecture Fabrication, Crafting the Future of Architecture with AR and Robots. So it's like moving the previous method one step forward. We are adding the human-robot communication and collaboration to this workshop as well. So we are trying to use the advantage from robots, which are the accuracy and efficiency, and as well as we are trying to use advantage from the humans, which are flexibility, right? So what you can see from this image is like we are using the robotic arm to place the current structures, and at the same time, the human fabricators, they are wearing the AR glasses because they can see the connection part, and they will use the screw to fix them. So by using this kind of method, we keep the accuracy from the robot as well as we keep the flexibility from our human fabricators. So not only applying this human-robot collaboration method, we also involve our AR-assisted guidance for this workshop as well to apply like more clearly visual guidance with all the index shown on that. So we achieved this kind of bamboo fusion pavilion within 1 week, including the design process, simulation process, and fabrication process at the end. So you can see with the help of augmented reality as well as the robotic fabrication, it really increased our speed for the physical fabrication. So here is also a small video that demonstrates this workshop. And also we exhibit this workshop for several times. So this is the Future Lab exhibition that happens in Shanghai. So this is the video for the Bamboo Fusion Pavilion. So actually we get the idea of the design from AI, and then later we translate that into Grasshopper for the final design. So you can see all of these elements, they have like different angles and different lengths for the connection. So we cannot send it to the factory for mass production because they cannot do this kind of very customized design for us. So our strategy is like to introduce the augmented reality method as well as robotic fabrication methods to our students. So at the first several days, we do the basic training of these technologies, and we did a small workshop for them to warm up. And later we are starting to do the design process. So you can see the first part is the structural part. And the whole structure part was designed in Grasshopper and fabricated by our Khoo robot, which already been introduced by Zhelun at the first session. So the robot, Khoo robot will pick and place the wood and then at the correct corner, and we will help to cut them. And then the robot will pick up again to the correct corner, and our human fabricator will wear the glass to fix them. So this is like a very straightforward fabrication workflow for this project. So not only about the structural part, we also involve the augmented reality method for the base part as well. So you can see our base is like a very unique shape, and we are using the scene simulator machine downstairs in our fab lab to cut the base. And then we are using the augmented reality method for us to assemble the base one by one. And then for the bamboo surfaces for this pavilion, we are combining the traditional Chinese bamboo tying methods. So you can see our fabricators, they are tying the bamboo strap with the traditional handicraft method and fix them on a frame. And also we need to bend them to make these surfaces. So for the distance of bending the part, we are guided by the augmented reality method. And these frames, we have 70 frames. So these frames are fixing the shape of the bamboo strap surfaces. So you can see these 70 frames, they also have different lengths for each element and different connection angles. So we are also using the augmented reality method to fabricate them, to measure and cut and connect them together. So at the very end, we are attaching different bamboo panels on the frames, and then we attach the frames to the structure. So this is the final result of this bamboo fusion pavilion. And then for the final fabrication part, we use 2 days for the final assembly part. So it's really fun. So there are some like very detailed of the bamboo fusion pavilion project. And then not only for, let's say, this kind of digital fabrication part, our department also trying to explore this immersive technology into the design as well as immersive experiments part. So this is a kind of a visual exhibition project that I did with my colleague Sylvia and Giancarlo together. And this one was a virtual exhibition which collaborated with Italian lighting company Iguzini together. So we are trying to move this kind of lighting quality into a virtual exhibition. So this project, we are using the Meta Quest 3 goggles to creating this lightning feelings as well as the real lightning effect through the goggle devices. So it is really convenient for our client to show this virtual exhibition hall around the world only with this device. So later we are currently trying to explore this VR experiments one step further, and we are right now doing the FYP final year project with some immersive museum design with the same technologies. So after the final year project is done, I will be able to share you more result of this kind of things. So I think I still have like one project to share with you together. So that project is not only not related to teaching or teaching. So this one is more facing to practice part. And this is a Wheelshark installation that I did together with the FabPop company, digital fabrication company in London, as well as the BEWS studio, design studio. And we are trying to create this kind of very giant art installation for 2022 Qatar Football World Cup opening ceremony. So this is an art installation, and it is not a rendering, it is a real-time photos. So you can compare with the human scale below to tell how big it is. So the whole whale shark is about 50 meters long and also 30 meters wide height. And this whale shark installation is hung in front of 4 high-rise buildings behind. So why they choose this whale shark? Because the whale shark means friendly, means welcome from the their culture background. So we came up a really crazy idea about hanging this very giant metal whale shark in front of their Soho Center. Because we got this requirement in a pretty tight time period, so they only give us 3 months for design and fabrication. And we are looking for several factories in London, and they cannot help us because this kind of very highly customized fabrications. So at the very end, we are choosing augmented reality methods to help us achieve it manually. So the design logic is like we are cutting this whale shark into different pieces, and then for different pieces, we are using the metal rebars, and we are trying to bend the rebars to simulate the whole shape of the whale shark. And this kind of rebars will be the skeletons. And then upon these rebars, we will attach several metal sheets to create the skin of the whale shark. So this is the AR-assisted fabrication recording for this art installation. And together we have 30 workers, and we work together with 2 months. And we bend all these kind of rebars manually. I think it will be together around 3,600 pieces of metal rebars. And then we attach around 7,000 pieces of metal sheet. So on the left-hand side, it is a recording from Microsoft HoloLens about demonstrating how we bend it, how we fix it. And on the right-hand side, it is the working process of one pieces of the whale shark. So you can see we fix it firstly on a wood frame, and then we weld them together. And on the middle part, that is the metal sheet guidance in AR. So we use the AR Vivint gun to fix the metal sheet onto the metal rebars. And this first image is the AR-assisted metal rebar bending process. So actually the workers, they can see their rebar as well as their rebar target. So what they need to do is they place the rebar at the current length and then press the toggle of the electricity bender to bend it to the current angle. So this is somehow of the workflow of this project. And then later, after we finish the pieces fabrication, we ship it from London to Qatar. So we, on the site, we weld them together on the metal truss behind it. So you can see compared to the real worker scale, how big it is for the weld truck tiles. So here's a final video of the final outcome, and then we also collaborate with the lighting company to add some light effect for the opening ceremony.
Project like this would typically take about 2 years, and we had to conceive it, design it, procure it, construct it, ship it, assemble it, lift it, and then program it in about 3.5 months.
The design itself is based on an idea that I've been exploring for many years, which is to take textile techniques, scale them up to a really big architectural dimension. One of the biggest challenges of the project was to lift the rail shaft into the position. He had experimented with a new technology. With the mixed reality headset, you can put on your glasses and you can see the actual piece in front of you. Those buildings were just not designed to support a 20-ton steel sculpture. It is a very challenging process from an engineering point of view.
I'm in the ocean, but now the workshop is in the air. There's a certain sense of magic there.
Okay, so I think the both cases that are some very special cases that I would like to share with you about my own mixed reality experiments for teaching and practice, and also not only limited to them, but also I'm quite open to the research direction of immersive narrative, immersive design, and building information visualization, immersive heritage, and also some human-robot collaboration things. So I feel like this will be the future trends of our architecture. So currently I'm trying to use different teaching chances as well as the practice chances to explore the possibility for the future. Okay, so I think that's all for what I would like to share for today's guest lecture. And later in the question session, if you have any questions, please feel free to ask. Thank you.
All right, thank you so much. And please give us a round of applause to both Dr. Zhelun and Dr. Jiaotong. Thank you. Okay, so now I would open the floor up for Q&A, but of course, there's people online, and we've also got our students here. I wish I could turn my laptop, but then I think it will mess up the cables, but we have quite a lot of students here today, and I hope there'll be a lot of questions too. But to help me out with that, I have Dr. Leong here to moderate this Q&A session. So yes.
All right. Thank you. Hi, Dr. Zhelun and Dr. Jiaotong. Hi, Kish. Thank you for the amazing sharing. I think Xi'an Jiaotong-Liverpool really have a strong team in digital fabrication, especially when you have both of you that covers the virtual and the physical, which is like the whole both field in digital fabrication. Congratulations to you all. So maybe for the students, maybe you can start think of what are the questions you want to ask. As usual, I know you need time to digest. So maybe I will start the first warm-up question for all of us here as an academician. To Dr. Zhelun and Dr. Jiaotong, I think, or Dr. Kish, I think you all can also chip in about this question. Okay, digital fabrication let us rethink about like the how the way we built. Like I think this happened so fast. I remember my degree time I was with, I did everything manually. The most is I do a pretty 3D and then that thing renders and it stops there. But today, I think within 10 years, machines has changed all this industry and robots come in. I mean, less human involved in all this construction. But for the architecture education, how do we see this as it happened so fast. Even last time when we study history, we start to remember all the styles. But I think after parametricism, everything's like, oh, too fast. They don't have a term to catch up with all these changes. And in architectural practice, I believe it's like a little bit of a top down. Like last time, we plan on the form, like historical parts that respond outside, respond inside. Then we have the section, the wall line. But now we rethink about the material that we have. Bricks no longer are rectangular. That means form finding, I believe these terms is a very new terms to digest. So maybe you can share, both of you all can share a little bit on how this digital fabrication process in academia. Maybe Dr. Zhelun, you can start first.
Sure. I think that is a very interesting question. And this emerging of digital fabrication process, of course, I think is a huge opportunity for us, not only from academia perspective, but also from practice, as Dr. Song Yang showed before of his personal experience. From my research interests, the digital fabrication and the design provides a huge, let's say, a scenario for our future expansion on the space. And speaking about a broader scenario that we must deal with some extreme conditions, right? We cannot allow human labor to put the pieces together anymore, right? Because we're facing different temperature, we face on the radiation exposure, on the moon, we exposure, there's no air, breathable air. So having robots to put the pieces together, we provide a huge opportunity to provide a construction process and methodology to stimulate that we can create some living settlements for the, let's say, this colony, right? But also we can explore different material that we have never used before and we didn't thought before. So one of the research paper that I read in this case is the use of water as construction material. Can you imagine how can you use water to build settlements, right? But it can happen on the moon because the average is 150 under zero. So the FDM methodology that we use on the Earth is usually using the plastic material like resin, right? But on the moon, you can just melt the ice and then use water that immediately become ice after you spring out on an object. And that's the use of materials that we have also on the Earth, but we never thought it could be a construction material. But just giving an example that you can use ice as people who live in the polar zones, right? Like igloos. Igloos is round snow actually, and there are also people who live in the South Pole. They use the ice blocks to build buildings. So these are some traditional inspirations, but for future, like if we are landing on the moon, we can also use these, let's say, traditional construction materials like block masonry system by using advanced digital technologies like 3D printing of the local materials, right? And you can use robots to place the materials on that site. I think this case is our frontier of our architecture exploration to use new emerging technologies to enhance our horizons, to allow us our creativity to build a better, let's say, living zones for future adventures while exploring lands, places outside of the Earth, of our planet.
Thank you, Dr. Zhelun. Maybe Dr. Yansong, you want to share a little bit on your thoughts?
Yeah, I quite agree with you. Like, I think at the time when I did my bachelor's, so that time like we did everything like pure manually, and then I start to learn how to use Rhino, how to use Grasshopper, and then after, by that time we are entering like this kind of digital era. So I still think I need like more time to learn about these technologies because currently we are into a new era of AI again. So I think we cannot like chase for the technology to trying to learn them one by one, but actually these technologies or all of these devices, they are helping us, they are advantage us or serving us for make like better design or better living qualities. So that's why we are currently exploring so many different materials, but not only with the basic material shape, just like what you said, like the brick they have been used for maybe 1,000 years, but now we are trying to explore more different shape of the brick because we have the opportunity that given by the digital fabrication, which we can also do like concrete brick printing or the clay brick printing to make the surfaces or shape more like designed or more reasonable for some sustainable requirements. And also from the fabrication material that Zhelun just pointed out for the water, in my hometown, actually, we use water for the fabrication as well because I'm from like a very north part of China. And then during the winter time, we are doing some like ice structures as well as some snow structures. So previously, they did this kind of things with drawing on top of a solid, let's say the snow cube, and then they need to mark it down and they take some part off. But now recently I saw that they are using the robotic arm for them to do like more hollow drawings on top of the snow cube. And also they use the augmented reality methods to make like to project it on the snow cube and then take some part off to make like more parametric shape of the snow structures. So I think this kind of digital fabrication, they are giving us more opportunity to create more crazy shape, I would like to say, but also we are trying to, we are not limited ourselves by this technology only. We also trust ourselves as a designer to judge which kind of material or what kind of design is suitable for what kind of devices or technologies.
All right, thank you. Maybe open to the floor. Okay, your turn to shine. Anyone? Can come forward to let the panel to see you.
You won't get a chance to get lecturers like this, especially, you know, when it comes to this AR, VR, all these new tech that a lot of universities are also, they are using now, you know, so this is really your chance because this is the future. I think you guys in Xi'an Jiaotong-Liverpool University, you're really living in the future. So it's pretty awesome. Or maybe you guys have a design question for him, because example for our interior architecture studio, you guys are pretty much looking into tessellated patterns and design right now, right? This is all related. Architecture as well, all these components, all these modular systems, same thing. It's basically the same thing. So you guys have your own personal design questions, you can also ask, you know, how to enhance my project, you know? Anyone? Don't be shy. Yay, thank you. But please come forward. And because the mic is here, and you can please introduce yourself and, you know, tell them what you're doing. Just don't worry, the mic is right.
Hi, hello. Thank you for your session today and your talk. My name is Muna, and I was actually interested about the types of the designs you did and the various sizes. And there was the one for the opening that was hanging in between the two buildings. It was really huge compared to the human size. So I was wondering, we saw like the small pavilions and we saw this huge type, and I was wondering how huge can actually these designs go, like how big it can be.
Okay, so that is something like related to the development of the device. So the reason why we make some small structure is because I can show you the device now because the device is right next to me. So it is we have all the things projecting on these two screens. So it depends on how wide that you can see, which can lead to like how big the structure that you can did. So the whale shark things is like we divide them into small pieces, right? And then we did the small pieces into a very reasonable scale. So the small pieces will be around like 3 meters by 3 meter, which is reasonable for human workers to bend and also attach. And later we combine all the pieces together to make these huge things. So I think it doesn't matter about how big it is unless you find a better solution to solve it. So because now the device, I would like to say, because this is a second version of the device, it still has some limitation about this kind of visual angles and the things that you can see. So later, maybe with the development of the device, we can see more wider and then we can make more larger project. But for now, I would like to say whatever you can see within your vision, that will be achievable for the design and the fabrication.
Thank you so much.
Okay, thank you. Well, we got one question from the web. Let me just read it out. Okay, it's from Misha Lopez. Hi, I just read that the whole words. Hi, I want to ask a question to Mr. Zhelun. From what I heard, space architecture seems as a pretty niche field, as many people remain skeptical about the practical feasibility and construction methods and material research in extraterrestrial environment. From your perspective, where do you see the future of space architecture? And the next one, what advice would you give students who are interested in pursuing unconventional or highly specialized fields such as this? Okay, to you, Dr. Zhelun.
Oh, that's really nice. Sounds very crazy as let's say, possible alternative scenario of architecture practice and design, especially in education, because we usually don't ask the students to design on the moon, right? So this is a very, let's say, common question that I've been asked for people, even though even during my doctoral research. So my doctoral research is about space architecture. And the doctoral committee asked me why you're doing this degree in architecture instead of, I don't know, astronautical or aerospace engineering. So my reply to the chair of the doctoral panel is that this is architecture problem, right? Designing settlements and habitats, even though in extraterrestrial environment is not engineering question, it's an architecture question. From engineering perspective, they fulfill only the minimal requirements. So that's like a list of checkbox. But what we do in architecture is something very different, right? We propose alternative, we propose better living conditions, we propose social interaction, we propose aesthetics, we propose something broader than just architecture, just the engineering solutions. So that's why I am very, let's say, excited of this research topic, and I'm truly interested to explore, let's say, different possibilities of architecture. And I also supervising students' final year project with this brief. And of course, there is an introduction lecture about the hostile and extreme conditions on the moon. But on the other side, we have a lot of opportunities that lead to different design exploration, like the low gravity, right? The gravity is always a nemesis of architecture exploration. But what if we can design in a gravity which is 1/6 of the terrestrial gravity, right? Can you imagine architectural shape can become if we can consider less of gravity and merging with also the innovative, let's say, design and the fabrication strategies like 3D printing, we can absolutely design wonderful and unconventional shapes for our building, which goes beyond the, let's say, the traditional. In this case, we can call niche field of traditional architectural design, right? We can absolutely unleash our creativity, human creativity, to propose something, some building which is not on the earth, not just physically, but also, let's say, different size and different types, different typology for our future building, right? And this for me is very exciting, and possible, let's say, direction that student can take can be aesthetical, can be material, can be technological, and as long as it is creativity driven. And we should base this exploration, of course, on rigorous academic exploration, but extraterrestrial environment provides a large and huge opportunity to unleash your creativity. There are already several schools and universities who opened programs in space architecture, like University of Houston and the TU Wien in Austria. They embedded space architecture as a possible, let's say, education system that can allow architecture and design students to think the purest meaning and aim of design, which is the investigation and research of design context, analyze it, and then analyze the human and the user's needs, and then propose our design outcomes. And the result is that you will find projects that the students are not just limited on the, let's say, case study or the usual design solution that you may find very common or, let's say, maybe obvious, right? But in that case, if all the, let's say, context can be fulfilled and the proposal is working, then that's a new, absolutely new design product. So for students that will who are interested in pursuing, so the second part is unconventional, highly specialized fields such as this. I would say don't get afraid by the very highly specialized fields. So that is a mistake that I've done when I was a PhD. When I started to think and get into really deeply into aerospace engineering, I should not, right? Because we are in an era that all the fields are merging. Everything is getting very specialized. You can learn, you cannot learn. It's not feasible that you learn everything. So it is very important that we create this interdisciplinary mindset, which doesn't require you to be a specialist or an expert in that field, but your mind must be prepared to accept things from others and try to emerge your personality, your creativity, and try to navigate in a system that you are not aware or unfamiliar before. And that's, I think, also is a big challenge, but also opportunity for design of 21st century, especially under AI, right? Because AI actually knows everything, but the good designer knows what is the good question. So I hope our student can be the one who asks the correct question.
All right, thank you. Thank you for your response. I totally agree with you. I can't wait. I hope that I can live until that age to see all this realized. And yeah, probably she can work with NASA. I think that competition that Norman Foster won was organized by NASA. I think it will be happening quite soon.
Yeah,
and
we are exactly. We are planning to land on the moon by Project Artemis by 2030, and also Chinese Space Agency is planning to land on the moon by 2030. So this is actually happening by settling on the moon. So it's something actually we happen. It's going to happen. right? So it's not so far. I hope that we can, we are in this area that we are going on the moon again after 50 years from Apollo mission. And all the space agencies around the world has planned as national strategic goal to go back on the moon again. So sorry I interrupt you, but just remember this is actually happened.
Great. Let's go to the moon.
Yes.
Okay, maybe we get another one last question because we are just on time. The last one. If no one here, I will take the opportunity to ask the last question. Maybe you want to ask, can I not learn technical drawing since the robot is going to do my work? Okay, never mind. Then I will ask the last one, maybe to Dr. Yan Song. I think you have a very interesting background with virtual reality and AR, VR. Maybe can you share? I'm interested with your work with your collaboration with So Min Han, absolutely amazing team. That can you share a little bit about the process of your work, especially in the rationalization parts and the calibration? I believe it's not easy to have all that set and then the students just assemble. Looking at the steampunk pavilion, wow, it's crazy. That whole structures is unreal. Or maybe you can share a little bit of your experience on this. Thank you.
Yeah, it's quite great that you know Sumin Ham design, because Sumin actually was my master tutor in Bartlett, and she is I think she was the first tutor who trying to explore augmented reality technology for, let's say, master level at UCL. So she has really great experiments about how to divide this kind of workflow. So normally, because I'm not involved in the steampunk project, but we did a steel fusion together. So the working is like normally we have like a discussion together and then have some brainstorm, and then we finalize a shape. And after that, I will focusing on how to change this one into the augmented reality part. So once you have entering this step, you need to think a lot about what kind of graphic design in the AR glass that will be really helpful for the student to understand. Because our student, they don't have any experiments of AR glasses. They don't know what they're gonna see in the AR glasses. So we just use like very simplicity design languages to demonstrate, to highlight the pieces would be fabricated or would be assembled, plus several text next to it to make sure like all the information they are delivered efficiently. And also we provide with our workers this kind of AR assisted training or rehearsal before that. So actually they can see the things on set into a one-to-one scale before they build it. And also they can see all the virtual steps one by one. So for example, our students for the pavilions, as well as the workers for the steampunk pavilion, they will see each step one by one. So before they do the real fabrication, they will understand how it works, right? So these are something in the virtual space. And in the physical space, actually, before we dismiss this kind of task to our student or to the workers, we will give them several trainings about how to control the AR system, how to play with the physical materials, especially for the steampunk pavilion. They are using the traditional steam bending method, right? So it's like placing the wood bar into a plastic bag, and then they add the steam inside of it to make it a little bit soft. So this kind of handicraft methods, as well as what we did for the bamboo fusion pavilion, like we need to use the traditional way to tie the bamboo strap. So we need to give like very detailed tutorials for our workers and for students, for them to get understanding of the material performance about this kind of handicraft skills. So normally before we entering the full speed fabrication process, we do this kind of virtual training as well as this kind of physical training together to make sure that everyone knows how it works, knows the workflow, and knows how the outcome's gonna look like.
Okay, thank you. So maybe with that, maybe we want to have a final words from Dr. Emma. Thank you so much both for sharing this wonderful session. Thank you, Kish, for being with us.
No, I'm just thinking like, wow, really, I'm glad he's here moderating because I don't know where to start, at least with the questions myself, but it's really amazing work and also really impressive. And of course, I hope I can try them out myself one day in person. So yeah, hint, hint. So thank you so much. But I think before we end today's session, I think thank you so much for the Q&A and for the questions online, and also thank you, Dr. Leong. But before we end today's session, I'll probably also like to, I will probably share about our joint summer workshop. So if you guys don't know already, I will put up the official poster soon, but today, this is the last of our Tectonic dialogue session, but it is not the last of our collaboration with Xi'an Jiaotong-Liverpool University. So this summer, if you're thinking about your summer holiday, where should I go? What should I do? And make it worthwhile, we are going to open a summer workshop between our universities, and you will have the chance to go over there to their campus in Suzhou, by the way, in China, to experience all of this and to potentially also exhibit your work in one of the cultural festivals. And yeah, it will be a 5-day workshop in Suzhou, and then we'll also have some fun. And I'll put up the official poster after this, and I'll put it up as well. But of course, as you can see, you know, there's a you see their Fab Lab. You'll be able to really get into all of this that they've basically highlighted and be a part of it as well. So yeah, I'd like to talk about that after I end this recording in detail as well. But other than that, thank you so much. Thank you for joining us. Thank you for this collaboration. And also thank you for sharing your expertise from Kish to Sylvia, Zhelun, and Yansong. Thank you so much. And I think, yeah, we'll please give the lecturers another final round of applause, please. I don't know if you can see them. I don't know if you can see them. Well, you better hold the. Yeah. So give your biggest smile, everyone. Please give your biggest smile. Wait. Can you see that? Oh, yeah, that's the classroom. So thank you so much. And I think that's about it, unless you have a question for us, all the students. But I think other than that, that's about it. Thank you so much.
Thank you. We really hope to see some of the UCSI students in Suzhou. We're really excited to, well, on my side as a Malaysian, always excited to see more Malaysians coming over. So please take this chance, sign up for the workshop, and hopefully we can work together, and we would love to take you around Suzhou. Yep, that's it for me.
All right. Thank you. Thank you. Thank you.
Thank you.
Thank you.
All right. See you another day. See you online again. Thank you, everyone. Thank you online as well.
Bye.
We'll end the recording, and thank you so much.